So if you actually pay attention to the syntax of these two different functions, it's uh, the 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 content of the function, basically the statement is almost identical. It's basically the same. It's all return two variables that's adding together, two objects that's adding together, and then it's just returning the result. The only thing that's different is basically the type, the return type. For these two functions, one is returning a float and the other is returning a string. And then the type of the two input parameters, one is float, the other one is string and string. So if there's a way for us to put the type as some kind of variable into the function, then we don't really have to write two functions. We can just write one function, but with the type that's kind of determined by how the function is called. And C++ actually provides a mechanism for you to do that, which is called templates. So we're going to comment out these functions first. And then let's write a different function. But this time we're going to write a template function. We're going to define a template, and then I'm going to use the keyword type name A, and then type name B. So here I am actually defining two type names. One is called A, the other one is called B. So template is a keyword that's defined in the C++ language, and then type name is another keyword. And by declaring that big A and big B are type names, I can use A and B to substitute the float and the string here. So now instead of writing a specific type, I can use some kind of variable for a type name. So this time I'm gonna write the body of the function first before I do the return type. I'm gonna do A F and then B G, and I'm gonna return F plus G. That's it. So in this particular add function, I have two inputs, F and G, but the type name for F and G is not sort of fixed. It depends upon what's going to be the calling function. The function it's going to be it depends upon how this particular function is going to be called. But the problem is that what's going to be the return type, right? What's going to be the type of F plus G? I have no idea. It could be A, it could be B, or could it be some other type that's different from A and B? I don't really know. So what I'm going to do, I'm going to ask the compiler to figure out what's going to be the return type. So I'm going to use auto here. So I'm asking the compiler to figure out what's going to be the return type for F plus G. Now let's give it a try. I'm going to save this file. And then we did not modify, we did not change anything. We did not change anything for the calling function. Here I'm still calling add with just the F and D with two floating point numbers. And then another number, or another call of add with two string as the input. But I have saved it. Let's build it. Let's see if it's going to pass the compiler. Yes, build finished, and without any error, error message. And now let's run it. So it has finished running. So this is the first call to adding two floating point numbers together. 6.28, that's the correct result. And then that's adding two strings together. You're adding two strings together. That's the second call of add hello world. So and the result is also correct. And so you can sort of see how powerful C++ language actually is. It's not only allowing you to specify variables that can hold content, either numbers, strings, or anything else, or objects, any kind of objects. It also allows you to specify the type of a particular variable as another level of variables. Here you're defining type names as variables actually. Essentially, in principle, it's not really variable, but I probably should not use the word variable. But you can sort of see you have made the type name that's kind of dependent upon how it's going to be called. So at this particular function called add f and d, and so the type name a for this particular call, the type name a is going to be float because f is actually a float. And then the type name for b is going to be double because the second parameter that's feeding into add is a double. And C++ actually knows to substitute a for float and substitute b for double. And then the return f plus g is probably going to be a double actually, and then it's going to return a double actually. So this auto is probably going to be just resolved to a double for the first call, for the first add call. And then for the second add call, the first parameter is going to be a string. S1 is going to be a string, and then C++ is going to automatically substitute a, replace a with a string. And then the second input is also a string, and C++ is going to replace b with a string also. And then the return is going to be a string plus a string. It's another string, so it's going to return a string, and this auto is going to resolve to a string. So that's sort of what we call the generic programming. It's another very strong capability of C++. It allows you to introduce another level of abstraction into your programming. Allows you to write less amount of codes and with the same kind of functionality. Here you're actually writing two functions, but now I'm actually just added one more line, and the function is actually simpler. With less typing, and you actually implemented the both capability. And suppose you can add, suppose you want to add not just the numbers together, but also numbers with strings or some other objects. For example, persons with persons. If you want to add two persons together, for example, you can define your own add operations for your own objects. Of course, you can define your own operators. How person add to person is going to behave, that kind of operation. It's perfectly fine to call this function. It's still perfectly fine to call this function. You're just giving it to one person and the other person, and then the type name a and b are going to be resolved to person, the class person. It can actually do that as soon as you actually define the plus operator for the person object, for the person class. So and you don't really have to add even one more function. You don't really have to define an add function for the person at all, and you can just keep using this particular function to do whatever you want to do. So that's sort of the one demonstration about how to use a template inside a function. So far, all we have talked about is about the data structure, how we can actually manipulate data, how we can actually construct data, and how we can actually sort of use data, that kind of thing. The data structure for C++ is actually quite big, and it allows you to express very complicated things using its data structure, and it's very expressive. It allows you to describe data in a very intuitive fashion. And we'll talk about data structures provided by C++ in a lot more detail in future videos. But now let's switch topic to talk a little bit about flow control, how you can do loops and how you can do branches. So let's look at how we can do loops first. We're going to start with some very simple loop structure that allows us to iterate through, for example, all the elements inside of this integer vector, a vector of ints. So let's try to write a loop using the keyword for. So for is a keyword in C++, allows you to sort of write a loop. So in this for construct, you have to sort of first you have to identify or define some kind of variable. So here, because it's a int array, it's a vector of ints, so I'm defining a int variable, that's an integer variable, that's called II. And then you use colon. And then followed by the range of II, which is the AI vector. So in this kind of syntax, what you're actually telling C++ is that I want a integer that's called II to go through every element inside of this vector AI. So let's give it a try. So we're going to just print out the content of II. And let's just compile it, build it, and then let's just run it. So it's basically looping through the entire content of AI. AI has at the beginning it was like to have just 5 elements, and then we did like 2 pushbacks. So now it has 7 elements in it, and the value actually goes from 1 to 7. So here it's actually printing out the values in AI from 1 to like 7. But suppose we want to do something that's kind of different. So if you are doing a for loop and the content of the loop, basically the loop body, if it has just one line, you don't really have to use curly brackets to enclose the body of the loop. But if you have more than one lines, you have to use a curly bracket to enclose the body of the loop. So suppose I want to not just go through every element in AI and look at the values inside of the elements. What we can do is to what we want to do is to achieve a certain effect. We want to increase every element inside of AI. We want to increase every element inside of AI by a value of 1, for example. So the incorrect way, the wrong way for doing that, my one kind of naive mistake is to do something like that. II equals to II plus 1, for example. So you're increasing II, and II actually goes through every element in AI. So I'm increasing II by 1, and then assign it back to II. But is that correct? Is that correct? This syntax actually can be simplified. So this syntax can be actually simplified by doing this plus equals to, by using this particular symbol. It's actually equivalent to II plus 1. It's equivalent to this thing. But in this case, you are just increase it by 1. And if your increment is exactly 1, you can still simplify it even further. You can just do II plus plus. So the name of C++ actually coming from this kind of syntax. It's one step beyond C, so it's called C++. So you are taking one step or increase II by 1. So that's called an increment by 1. But this is not the correct way for increasing every element in AI by a value of 1, because the value is not going to change. The value the value of the elements inside of AI is not going to change. So if you don't believe me, you can still repeat repeat this loop. Suppose I do JJ or something and then see out JJ. So JJ is still going to be going from 1 to 7. It's not going to go from 2 to 8. It's not going to do that. Let's just build it, and then let's run it. So you can sort of see at the beginning, every element in AI goes from 1 to 7. That's from here. And then for the second loop, that's sort of here, JJ still goes from 1 to 7. So it's not really changing the values inside of AI. So how to actually sort of change the value inside of AI? So you can do this. Instead of define a int II, what you can do is to define a int ampersand II. So what exactly is this particular symbol actually mean? What does this particular symbol actually mean? It means that I don't want to just take the value. I don't want to just have a copy of the value that's the of the value for each element inside of AI. I actually want a handle to every element inside of AI. So this int end actually means that in C++ language this is called defining a reference. A reference is what? A reference is like having an alias of the stuff that you are referring to. So everything that you change to the alias, it's going to reflect exactly to the variable that you are actually referencing to. So this is more like a symbolic link. This is defining like a II is just like a symbolic link to the variable that's actually it's pointing to. So everything that you are doing to II is gonna reflect it on the variable that's II is referencing to. And in this particular loop structure, II is gonna reference to every element inside of the AI. And if you actually make this particular change, you're gonna get the correct behavior. Now JJ is gonna go from 2 to 8 now. So because every element inside the AI has increased by a value by 1. So if you want to build it, and then you can just test it. So now II before doing this before you make the increment II the elements in AI goes from 1 to 7. That's here. And then after you have made the increment, that's for this particular loop, for this JJ actually goes from 2 to 8. So that's one utility of using a reference. So a reference is like an alias or like a symbolic link or soft link to some variable that you are actually pointing to. So everything that you do on the reference is going to apply to the variable that it's referencing to. And this is actually how we can actually write a loop structure. And this is what we call a range for loop. So this is called a range for loop. Range for loop. We're going to look at the other ways of writing the for loop in a little bit later. But the range for loop is a constructor that's kind of similar to scripting language, for example. Some of the scripting language allows you to do this kind of for loops. So now let's look at a slightly more complicated example. Here we have another vector that's called AP. This vector is a vector of persons. A person is a class that we have defined as here. It has some data members, public data members. Has a string of name, a name string, an age integer of age, a string for male or female, and then a vector floats about the vitals, and the vitals is going to include the heart rate, and the blood pressure. So that's the vector of AP. It has 30 elements in it, and all the elements has been initialized to this particular information. So everyone is going to call Kevin, and going to be 25 years old, going to be male, and then the vitals are going to be 75, 120, and 90. 3 numbers in the vitals. So suppose we would like to increase the age for every element inside this AP vector by 1. So how can we actually write that using a range-based for loop? So we're still going to write a for, and then our variable, what's going to be the type of our variable? So every element inside this vector person is going to be a person. So we're going to do a person. Don't forget to use the reference if you want to change the element. Actually, if you want to make changes to the stuff that's inside of this vector. So we're going to define a person. Let's just call it a PP, for example. And then it's going to be colon, and then AP. And then that's pretty much everything that we need for the range for construct. So if we wanna increase the age of every element, all we have to do is to access the age to access the age member. So if you type a dot, the ID is actually giving you a drop-down menu, asking you to select from some of the possible data members, for example. So I'm gonna select the int, for example. That's the integer, the age, I mean. And then I'm gonna do plus plus. I'm gonna just increase the age by 1. So that's gonna increase the age of every element inside of this AP vector by just 1. And let's see if it's gonna compile. So it passed through the compiler. Looks like this is a correct code, but it can be simplified. We can ask, for example, the compiler to figure out the type for PP. We can ask the compiler to derive the type for PP, for example. So we can actually replace person here with auto. So now if you actually move your cursor to PP, the ID is actually telling you it's a person. So if I type F2, it's actually a person reference PP. It's a reference to a person, basically. So you don't really have to know what's actually the exact type for this variable that's going to range through every element in AP. All you have to do is to ask the compiler to figure out the type for you by giving it an auto. The same is also true for this particular example that we have discussed already. So you don't really have to put a int here. You can just put an auto here. And then that's also going to work. So if you move your cursor here, it's telling you it's a reference to a int. And if you move your cursor here, it's telling you it's a int. It's a int. So the compiler can actually figure out what's actually going to be the correct type for this variable. And then let's try to check. Let's see if we have increased the age, because the age for every element inside of AP is initialized to 25, and we did not make any changes since then. So this is the first change we're going to make. So the age for every element is going to be increased to 26. So let's try to print out what's going to be the age after this increment. So let's just check the first element in AP and the last element in AP, and let's see if that's the correct age, 26. So one particular way of doing that is by just typing 0 and then access age. And then for the last element, we know there's 30 elements in it. So the last element is going to be 29, and then access the age. That will work. Let's compile it, and let's run it. So it's 26. But I'm going to show you another way of accessing elements. That's accessing elements in a particular container. That's called by using the iterator. So you can actually use the iterator to go through every element inside of a container. So what I'm going to do is to do it in a different way. I'm going to call AP dot, and then I'm just going to wait. The ID is going to show me a drop-down menu, and I'm going to select from this drop-down menu a function that's called begin. The begin takes no input. It's a void input, and then it gives out, it returns a certain type that's called, you can sort of see what's actually, so colon is a scoping sort of operator. So basically what you are looking at is something that's called a constant iterator, that belongs to this whole thing, the vector, person, allocate person, that kind of thing. And then this thing belongs to std. So I'm gonna do this thing. I'm gonna do dot begin. So it's going to return, this particular function call is going to return something that's called a const iterator. What you can do, you can think of an iterator as some kind of pointer. It's another type of alias, another type of handle that allows you to manipulate the stuff that's inside of your container. And begin, this ap.begin, this begin member function of this AP object, this that belongs to, that's actually a vector, actually returns a pointer or iterator that points to the first element inside of this array, inside of this vector. So how do you actually access the member, the data member that's sort of pointed to by this particular iterator? You use an operator that looks like this. It looks like this. Looks like an arrow. You use this operator to access its data member. I have a data member that's age. So ap.begin is going to return the iterator, and that iterator is going to point to the first element inside of the AP vector. That's equivalent to AP0. But what you are actually getting is not actually AP0, but a pointer to AP0. So if you want to get the data member from AP0, you have to use not dot anymore, but you have to use this arrow. And then let's see if so now let's look at the end. Again, I'm gonna type AP dot, and then it's gonna be the last element. So I'm gonna look for another function that's called end. That's right here. It also takes a void as input, so it takes nothing as input, and it's gonna return another const underscore iterator. You can see that. And this iterator is going to point to one position after the last element inside of this AP vector. So if I call end, this particular function call is going to return an iterator that's pointing to one position after the last element inside of this AP vector. So if I want to get to the last element, if I want to get an iterator that points to the last element inside the AP, I have to subtract 1. So iterator accepts this kind of arithmetics. So you can add numbers to the iterator. You can subtract numbers to the iterator. So what it's gonna do, the effect of this kind of arithmetic is that it's gonna move the iterator back and forth. So by subtracting 1, I'm actually moving the iterator back by 1 element. So AP and subtract 1 is going to point to. It's going to point to its iterator that's exactly pointing to the last element inside this vector. Again, I can access the age by using this arrow, the age data member by using this arrow. So this is a different way for you to access the beginning and the end of the elements inside of the container. And the advantage for this particular way for accessing it is that you don't really need to know the size of the vector. You don't really need to know the size of the container actually. So let's comment out this particular line, and then let's save it and then compile it, and then let's run it. So this time it's still going to return 26 as what we were expecting. So now let's write a loop. Let's write a for loop using the iterators, using those iterators. What I was telling you is that the iterator actually accepts this kind of arithmetics. You can add numbers to it. You can subtract numbers to it. So let's try to write a for loop using the notation of iterators. So I'm going to write a for, and then what I'm going to do is I'm going to use auto, and then I'm going to define a pp. But this time pp is going to be equal to ap.begin. Semicolon. So this kind of for loop is going to look like a traditional C for loop. The for loop in you have an initializing statement. So basically you are asking the compiler to figure out what's going to be the type for PP. The type for PP is going to be the return type of ap.begin. So if you move your cursor over here, does it actually tell you anything? Okay, the ID is not really responding to me, but anyway, that's and then what's going to be the criterion for stopping the iteration? So here is the initializing the iterator, PP. Now let's try to specify the condition for stopping. So PP not equal to ap.end. So PP cannot be cannot be equal to the one position after the last element. So this is an assignment. This is not a comparison, but this is actually a comparison. Not equal to. You have to make sure that PP is not equal to. And then, how do you actually make increments on PP? You do plus plus PP. Plus plus PP is just similar to PP plus plus, but there are some subtle differences that we'll cover in a later video. So we're going to do plus plus PP. Plus plus PP is equivalent to PP equals to PP plus 1. So you are basically increasing PP by just 1. So this for loop is going to construct the iterator that starts from the first element in AP. And then it's going to add 1 to PP for every iteration. And what I was telling you is that adding 1 to the iterator actually means that you are moving the iterator to the next element inside this container. And the stopping criterion for the for is that PP cannot be equal to one position after the end of the AP element, AP vector. So basically, that's how you actually sort of do a for loop by using the iterators. So PP becomes an iterator that points to every element inside of this AP array. So how I'm gonna increase the age by 1. So I'm gonna so I have to access the age data member. So I'm gonna access the age data member. How am I gonna do that? I use the arrow key here. Just a dash and then larger than that. Use the arrow key and then age, and then increase it by 1 plus plus, and then that's it. So that's another construct of for loop, but by using iterators. You initialize a iterator PP by calling the ap.begin function, and then you increase the PP by 1 for every iteration of the loop, and then you specify a stopping criterion. PP cannot be equal to the last one position after the last element. And now let's check the result. This time, because I have increased the age by 1 here, using this range for loop. After this range for loop, it's going to be 26, and then I increase the age again in this iterator-based for loop. So now the age should be sort of 27 now. So let's see if that's true. Okay, 26, 26, 27, 27, but looks like I forgot end of line. So ENDL, ENDL, ENDL again. So let's recompile it. But you can sort of see the result is actually correct. So 26, 26 after the range for loop, and then 27, 27 after the iterator for loop. So that's another way of writing a for loop for general containers. Actually, we've looked at the range-based for loop, range for. We've looked at the iterator-based for loop, iterator for. There's still a third way for writing a for loop, which is sort of the old-fashioned way. So you do that by defining an iterator, or a loop counter. You define a loop counter. So suppose we define it as I equals to, initialize it to an unsigned int, and then initialize it using 0. So here I'm defining a loop counter I and then I has to be smaller than well AP dot size, and then plus plus I. So you initialize the unsigned int I here, and then you increase I by 1 for every iteration of the loop. And the stopping criterion is that the I must be smaller than the size of the vector AP. So that's sort of the old-fashioned way for writing a full for loop. It's not too complicated either, and it's also used widely. And if you still want to increase the age of each of the patient by just 1, you can do it this way. Again, AP. Now you can index into AP, the vector AP, so you're basically taking out the ith element of AP, and then you access the data member dot age, and then plus plus. So this way you're actually so this is a direct access to the age member of the API element of the AP vector. And if you wanna print out the result, this time the age for every patient should be just 28 now. Because here I increased the age from like 25 to 26, and then here I increased the age from 26 to 27. Now I'm increasing the age from like 27 to 28 now. So let's save it, compile it, and so now the age is like 28 now. So loop counter 4. So we have looked at the 3 ways to write a for loop: the range-based for loop, the iterator-based for loop, and then we have the traditional way by defining a loop counter. So one of the things that you have to sort of understand is that for this particular loop counter, this is unsigned int, and you define a variable that's called I, and this I is gonna have a lifetime just during the loop. So if I try to access I outside the loop, outside of the loop construct, then it should be undefined. So this is related to the scope of variables, to the scope of objects actually. So the scope of the objects is actually a quite complicated subject. We'll talk about that later in a later video. But for now, we should sort of pay attention to the scope. So here I actually have a auto reference II, and this II should be an integer because it ranges through AI. And this II has a lifetime just inside of this for construct, and outside of this for construct, you don't really have a view of the II variable. And then for this particular for loop, you have another auto variable that's JJ, should also be an integer. And this JJ only has a lifetime inside of this loop construct. And outside of the loop construct, the JJ should not exist. And then you have this thing. PP should be a person. PP should be, but this PP variable should only have a lifetime within this loop construct. And then the same thing is here. So this PP is sort of an iterator. It's an iterator pointing to the AP vector. So, and this iterator will only live inside of this for construct. Should not exist out of it. The reason that you don't see the curly brackets is because you have just the one line here in the for loop, so you can neglect the curly brackets. But the fact is that it's actually equivalent to with the curly brackets. So So again, PP is still gonna just live inside of this for loop construct. The same is true for this for loop here. Uh, so the loop index I should have just a scope that's within this for loop. So it's important to understand what's actually going on for the either for the range for which you have a sort of a variable or reference that's sort of inside of the ranging through all the uh, elements inside the vector, or you have an iterator that's sort of moving across the entire vector, or you have a loop counter. These things actually only lives within the within the within the loop construct actually. Now let's look at a second kind of a loop constructor that's called a while loop, and let's try to understand how we can actually use a while loop in our C++ code. And we'll also look at a little bit the conditionals, because the while loop will require some kind of a condition for you to actually keep iterating. So we'll look at the conditionals and also if else this kind of construct, this kind of branching construct. Um, but before we do that, let's try to sort of understand how we can actually read text files into the C++ code. So so the how do you actually do the input output, right? It's not only from files but also from other kind of input device, for example. And C++ actually represents any kind of input output device using what they call a stream. A stream. So the stream can be binded to a file stored on a disk, for example. In that case, you can read from that stream, which is equivalent to reading from a file that's stored on disk. But C and C++ are not used just on a desktop setting, in which case you often read and write from and to files on disk. But for example, if you are actually using a cell phone, you are writing an application for a cell phone, and then your input device is not just a sort of a file that's kind of stored on a sort of memory, some kind of flash memory in the cell phone. You can also have other kind of sensors that it can become inputs. Um, so so the stream is some kind of a C++ class or some kind of a C++ representation of any kind of a input and output device. And if you want to have a stream that's sort of for you to read files that's stored on disk, you have a special class that's called IF stream. So I represents input, F file, so it's an input file stream. It's a class that's defined in C++, and you can use it to define an object of a input stream, input file stream. Let's just call it a person file. And then this IF stream has a constructor which allows you to specify what's actually the file name on your file system. Let me just give it the file name, home temp persons 2.txt. So this way you actually have sort of define a person file, this kind of IF stream object, and you are actually calling its constructor, the constructor function, and then the constructor takes the file name as one of its input, and you can just give the constructor the complete path to the file name. If it's under the current directory, then you don't really have to specify all the. You can just do, if it's under the current directory as your source code, then you can just do that. But 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 in this case, it's not true. It's not under the home current directory, so it's you have to give it a complete path. So that's how you actually can construct a IF stream. So now let's try to read from this IF stream and try to sort of store the information that's kind of stored in this particular file. But before we do that, let's just take a look at what's actually the content of this particular text file, persons2.txt. I'll try to open it in a text editor. So So the content of this particular file looks like that. So you have a first name, a last name, and a sex of this person, and then the age of the person, and then the vitals, the three vitals, the blood pressure, the heart rate, and then the two blood pressure. So it's basically the kind of medical information for about 50 persons, I think, 50 people. The last line is like 50. So we'll try to read the content of this entire text one line at a time, and so let's try to read it, right? And before we can actually read it, we need to make sure that the file is actually opened correctly. And in this case, you have to sort of use a if construct. So how do I test if a file has been opened correctly? The person file, this ifstream object, actually allows me to test that. And it has a member function, person file, sorry. And it has a member function. If I just do a dot and then wait for the ID to give me the drop-down menu, there's a member function that's called isOpen. It's here. So the is_open takes no input because the input is void and returns a bool. A bool is a data type that's called a boolean. So if you have a variable that's a boolean, then it can hold just one of two types of values, either true or false. So if you actually call this isOpen, it's gonna test if the file has been opened correctly, and the return value is either true or false. And if this if construct, if statement, is gonna take a look at the returned value. If it's true, then it's gonna execute this pair of curly brackets, whatever commands that's inside of it. Otherwise, it's gonna execute this body of commands that's following the else keyword. So do you see how you can use the if else construct? The curly brackets are important, but if you have just one line of command or one line of statement, you can neglect the curly brackets. If you have multiple statements, then you have to use the curly brackets to enclose the body of the branch. So let's write the else. Let's write the else first. Else means that the person file dot is open returned a false, which means that the code could not open this particular file. There are lots of reasons for the opening to be sort of unsuccessful. For example, if you specified the wrong file name, and you don't have that particular file on disk, so that could give you some kind of error for opening. So that's one of the possibilities, right? So if that's the case, we'll send something to the standard error. So CER is the C++ representation of the standard error. You can send something to the standard error, and then later on you're gonna look at what's gonna be the after the execution of the code. You can sort of take a look at what's gonna be the error message. But what's gonna be the error message? We're just gonna say unable to open input file followed by end of line, and then we're gonna just jump out of the execution of the code. We're just gonna do exit 1. So exit 1, this exit command actually is actually a C code. Actually, it's a C statement. So one thing about C++ is that the C language is actually a subset of the C++ language. So in C++ you can call C functions perfectly fine. It's completely fine to call C functions, to use C language inside of the C++ code, and the C++ compiler will actually take it without any kind of problem. But the exit 1 is actually not a very good way. It's actually an ugly way for exiting or handling the error. C++ provides a better mechanism for you to handle error messages inside of your codes. exit 1 is just gonna completely stop the execution of the code. It's not gonna really do any kind of error handling. It's just exiting the code. So if you actually look at the return 0, if your code actually has completed successfully, it's gonna come to this line. So it's gonna return a 0 back to the operating system, and the operating system will understand that your code has finished successfully. But if you do an exit 1, then the execution is gonna jump out of this code and return a status of 1 back to the operating system, and the operating system will understand there's something wrong with your execution. It's gonna consider that your execution has failed for some reason, because the return status is not 0, it's 1. So that's the else part. Your opening has failed. You failed to open the file. In the if part of the code, we're gonna write the while loop. But before we actually do the reading, we're gonna define a string. Let's just call it line, because I'm gonna read the text file one line at a time. So the content of each line has to have a place to store it. So the string is gonna hold the content of each line, one line at a time. And then I'm gonna write my while loop. So the while loop has to have a condition following it. So inside of this parenthesis, I'm gonna specify what's gonna be the condition. And then inside of this, and the while loop has to have a loop body. If the loop body has just one statement in it, you can neglect the curly brackets. But if you have multiple statements, you have to use the curly brackets to enclose the loop body, the statements that you want to iterate every time the condition for the while loop is true. So what's gonna be the condition? What's gonna be the condition for the while loop? We're gonna actually use the return value of a function call. That's called getLine. The function call we are gonna do is called getLine. And this getLine is gonna take two inputs. The first input is gonna be the ifstream object. That's called a person file in our case. And then the second input, which is actually essentially also an output. Actually, it's the variable that you're gonna store the line actually. So the getLine is gonna the getLine command. This getLine command is gonna read this ifstream, but it's gonna read until it sees a new line character. A new line character is basically a carriage return. And then it's gonna store the stuff that he has read until the new line character to this string line. And so you can think of the line, this second input parameter, also as an output, because the content of the read is gonna be stored into the line string. So that's for just reading one line. GetLine itself will just read until the first, for example, the first carriage return, and then store the content it has read into the line without the carriage return actually, without the carriage return. And then if you do a getLine again inside of the person file, then it's gonna read starting from the previous new line and then gonna read until the next new line character. So it's gonna read a second line actually. Again, it's not gonna store the new line character, but it's gonna put the content of this second line into the line string. So as long as you keep iterating, this getLine command will keep reading from the person file one line at a time, and it's gonna replace the content inside of the line with the new content inside of the person file. And the return type of this getLine actually depends upon your position inside of the file. If you actually have reached the end of the file, the return type, the return value is going to be something that's can be treated as a boolean and has a boolean value of false. So if it has reached the end of the file, it will return a kind of bit pattern, and that kind of bit pattern is going to have a bit that the end of file bit is going to be set, and the while loop, the while statement is going to look at that return type and then treat it as a false, and then it's going to stop iterating because it has reached the end of file. So this is actually a quite elegant way for reading into a text file one line at a time, and also at the same time you return a type that based on your position in the file. You return a value that's based on, and if you want to continue iterating or not depends upon the returned value, if it's true or false. So get line is a very good way for you to actually read the text file one line at a time. Then what's going to be the loop body? So for this particular example, I'm not going to sort of do very complicated processing, but we'll try to sort of move the data into the vector AP in a little while. But for now, let's just echo back the content of the line, because the line is not going to store the end of the line. So the get line is going to discard the new line character. So I have to sort of print out the ENDL, end of line, after the content of the line. So let's see what's going to happen. But before we actually run it, we need to make sure that after we have finished reading from this particular input file stream, we have to close it. So the statement for closing it is just the command, the function call for closing this the input file stream is just .close. So the input file stream IF stream has a member function that's called close, and it takes no input. It doesn't have to take an input. And then this way the input file stream is properly closed after you have finished reading it. So you have to make sure that every file that you have opened, you have to close it after you have finished reading from it. So that's one thing that's very important. You have to sort of remember to close it. And the member function for closing an input file stream is just a .close with a parenthesis. So now let's try to execute it. Save it first, and then compile it. And then now let's just run it. So this is sort of the last line of the text file. It looks like it has finished successfully. Yes, absolutely, it has finished successfully. So that's how you can actually read from a text file. But now let's look at how we can actually store the information into that vector AP. Let's try to write the codes that's gonna store the content inside of this person file into our AP vector, the array of persons or vector of persons. The first thing we're going to do is to define a string stream or input string stream. Here we have an input file stream or IF stream. Now let's define a input string stream. So this is inside of my while loop. So I have, for now, I have just a one line that's going to echo back to print the line that it has read from the text file using get line, this command. I'm just echoing back, printing it back to the standard output with the end of line. So now let's try to do some more processing of this line, this one line. I'm going to define a string stream. So what I was telling you, a stream can be bounded to any kind of input device. For now, the input device is going to be a string actually. So we're going to use a string as an input stream. So it's I input string and then stream. So iString stream is another object, another class that's defined in C++, and we're going to define a iString stream object. Let's just call it str. And this iString stream also has a constructor. It actually allows you to construct a iString stream object with some sort of initializing string. So the initializing string that we're going to give it to str is just the line that we just read from the text file. And then let's That's our iString stream. Now, we also need a few variables that we can hold the content that's going to come out of this str iString stream. So the reason I'm going to need those variables is because what I'm going to do is to do this kind of thing. So do you still remember this particular operator that's larger than sign? When we did the standard, when we try to read from the standard input, I still have that line here. I think it's when we try to read from the standard input or cin, we're using this operator to read from the keyboard. You can actually get those different text from the standard input or the keyboard into those variables. Here I'm actually reading two numbers, an integer and a long double. So I'm going to use the same thing. I'm going to take the stuff that's inside of this iString stream, which has been initialized using the content in line, in the line string, and then I'm going to sort of split it into multiple variables. I'm going to split it into a first name, and then a last name, and then a sex, and then the age, and then the vitals. The three floating point numbers for the vitals. So I'm going to need all those variables to store the stuff that's coming out of the str. So first, last, and sex are all strings. So what I'm going to do is to do a string. First, last, sex. And then age is an integer. I'm going to do a int age. And then I also need a vector of floats to store the vitals. And I'm going to call the constructor for vector here. I'm going to initialize it to. The vector of floats is going to have 3 elements in it, and everyone is going to be initialized to a value of 0. So that's going to be my variables that's going to be used for storing all those stuff that's coming out of the str. So that's first, last, sex, age, and then the vitals, right? Vitals 0, vitals 1, and then vitals 2, and then that's it. I have finished reading from this particular string stream. There's no reason for you to actually close a string stream. It's just a string actually. There's no way you don't really have to sort of close it. So basically that's how you wanna sort of read from the str. So now all those information has been stored in those variables, but how am I going to move those information into AP? Don't forget AP has an initial size of 30, but the text file is actually longer than 30. It has 50 pages in it. So how are we going to handle the stuff that's the 20 pages that's sort of already sort of outside of the range of the AP? So here let's define a new environment. Let's define a new variable that's an unsigned integer, IP equals to 0, and initialize it to. We're going to use this variable IP as our loop counter. And when this IP actually has increased to beyond 30, we're going to do a pushback to actually dynamically grow the AP vector. But if IP is smaller than 30, the length of the size of the AP array, we can keep using the AP array and put stuff into the existing AP array. So this unsigned int IP is going to be our loop counter. We're going to use that to determine if we want to store it into existing AP vector or if we want to do pushbacks to grow the vector. So what we're going to do is to write an if statement here. We have to, but if we want to use IP as a loop counter, we have to increase it for every iteration, right? So at the bottom of the while loop, I'm gonna do a IP plus IP. So I'm gonna increase IP by 1. But before and then I'm gonna insert some codes between them. So plus IP is gonna be the last line in my while loop body, because you don't want to increase IP, the loop counter, until sort of you have finished doing everything that you want to do during sort of one iteration of the loop. And now let's try to sort of get stuff into the IP, the AP array. So here I'm gonna use the if statement again. If IP is smaller than AP.size, which means that I I still have enough room in the AP array to hold new information from the file. And then what I'm gonna do, I'm just gonna access the IP's element in the AP array. Name equals to first plus space plus last. That's gonna be a concatenation of a string that's in sort of the first name, in storing the first name, and then a space, and then a string for storing the last name. Then AP dot sex equals to sex, and IP dot age equals to age, and then IP dot vitals equals to vitals. So basically that's the different fields. That's the different fields inside of the person class, right? So AP basically returns a person, and the person class has data members, right? A string for name, an integer for age, a string for sex, and a vector floats for vitals. A string for name, a string for sex, an integer for age, and a vector floats for vitals. And you are basically assigning them to those data members. So you cannot sort of confuse, even though the names for those variables are kind of sort of similar, right? But it's not the same thing. So this particular sex on the left hand side is actually the string sex that you define here, and then you fill this string with the content that's sort of inside of the file. And on the right hand side, you are using dot sex, so it's a data member of the person class. In fact, the name of this particular variable is actually AP square bracket IP dot sex. It's not sex, but for on the right hand side, the variable name is just sex. It's just a string. It's just string sex. So this is for IP smaller than AP.size. Else, what you want to do for else is to do a pushback, AP.pushback. So I'm going to push back what? I'm going to push back because AP is actually a vector of person. So what I have to push back is an object of person. So this pushback is a function of the vector itself, right? You have to push back. You have to push back a certain element of this vector, and this AP vector is a vector of person. So every element inside of the vector is a person. So what I have to push back is actually a person object. So in principle, I have to construct a person here. So I can construct a person, and then I can initialize it by using the universal initializer, the curly brackets. So I'm gonna give it how do I actually initialize it? First, I give it the name. First plus space plus last. That's the name, right? I have to actually initialize it based on the ordering when I define the class, and then give it the age, and then sex, and then the vitals. Give it age, and then sex, and then the vitals. So basically, I have sort of constructed a person P, and I have initialized it using this set of data. Now I can push back P. So this by calling pushback, I'm actually adding this particular variable to the end of the array, to the existing array AP. And then that's pretty much everything I want to do for the body of the while loop. and I can just increase my loop counter by 1. And suppose I want to sort of take a look at the new information. Suppose I want to take a look at the new information in the new AP vector. For example, if I want to sort of do a cout ap.size, this time the size is going to be 50, right? It's not going to be 30 anymore. And then suppose I want to sort of look at the name. Suppose I want to look at the name of the first and the last person that's inside of my new AP array. What I can do is to ap.begin, right, to get the first iterator, the iterator that's pointing to the beginning of it, and then I ask for to get I get the name data member, put an end of line, and then cout. I'm going to do ap.end, subtract 1. Again, I'm getting the data member name. And let's compile it, and let's see what's going to happen. So that's the last 3 lines that I have just printed out. So the size of AP has grown to 50. The name of the first person inside of my file, that's this name, and then the name of the last person, that's this name. So if you want to sort of compare them, the last name is the name of the last person is here also, because I have the cout here. Right? If you want to see more information, you can just access more of the sort of data members, right? So one way to simplify this code is to remove this line. You don't really have to explicitly construct a person, a P object. What you can do is to move this line inside of this pushback. So you can construct a person on the fly. In this case, you don't really have to introduce one additional variable, one additional object, person object. So basically, you're actually pushing back. You do a pushback for a person that's constructed on the fly, constructed and initialized on the fly. So here you're actually calling the class person with an initializer, and then that's it. That's it. So you can basically just it's gonna function exactly the same. Actually, it's gonna give you exactly the same output. Exactly the same output. So that's one example for you to read from a text file 1 line at a time and do some processing. And then store those information into a vector. So the command, the statement, the important thing that we have looked at, one is the while loop, how you can actually use a while loop. And then another constructor that we have looked at is the branching constructor, if else, the syntax for doing that, and how you can use it, right? And another important thing that we have looked at is how to open files and read files from it by using the getLine command. So it's actually quite a long example, so it's important for you to sort of understand how this actually worked out. And another thing that we haven't sort of discussed in detail is sort of the scope again. Again, the scope. All those, for example, this string stream is defined inside of this while loop. So it's going to have a scope just inside of this while loop. Outside of this while loop, you don't really have access to this str object, iStringStream object. All those variables that you have defined here are sort of only lives inside this while loop. So it doesn't have any kind of conflict with some of the names that I might have used earlier. It doesn't have conflicts with them. So this is just these kind of local variables that's sort of within this local scope is gonna sort of shield or sort of hide all the kind of names that's kind of defined outside of this local scope. And for example, this IP, it has a scope because it's defined inside of this if statement, if construct. So it's gonna have a scope just inside this if branch. outside of this if branch, it's not going to be visible. So it's not going to have any conflict with other variables that's defined, or other names that's kind of defined outside of this if construct. Um, we'll have a video that's going to talk about the scope in more detail in a later video.